Hello everyone. So in our last class we discussed about preparation of alcohols by first method using alkene, and there I told three reagents. First type we are taking the propane extract or alkene, acid catalyzed hydration, hydroboration oxidation. These two I wrote, and one more we will study today. So it is called oxymercuration, demercuration. Oxymercuration, demercuration. And by these two methods here, first and last one, so we can get CS3, CHOH, CS3, CS3, CHOH, CS3. Yes, in both the cases, it may be acid catalyzed hydration of alkene or oxymercuration, demercuration of alkene, and they can give same product, and they follow Marconi curves rule. They follow that addition follows the Marconi curves rule. But HPO method, hydroboration oxidation method, so this one follows anti-Marconi curves rule. This again water is added to the alkene molecule, and the OH group attacks on CH to not at CH, and it shows it follows what anti-Marconi curves rule. Therefore, we get a product CH3, CH2, CH2, OH. Yes, these two have worked. And by this method, yes, yesterday I told, is there any what formation of carbocation? No. But here there is a carbocation. Formation of carbocation occur in acid catalyzed hydration. No carbocation formation. Hence, in this case, the molecule may undergo rearrangement. But here, no rearrangement. Hence, always, OH group ends with that carbon which contain more number of H in case of HBU. HBU. Then, in case of HCOAC, there is a mercuric acetate. AC equal to CS3COO. CS3COO. There is called acetate. Now we will explain about oxymercuration, demercuration. But this is not there in the theory syllabus. But questions based on this one we can expect in competitive exams. You see the mechanism how water can add to C/C using mercury catalyst. That is called oxymercuration, demercuration. C double bond C H2 CS3 plus H2 of CS3 COO CS3 COO HC, or we can write this one as HCOAC twice. This is mercuric acetate. Then during reaction, right? So you can add THF and water. THF is 2. Next, H2O contain HOH. Now consider the bond breaks here, and O negative, Lz positive, O negative, Lz positive, and this Lz positive attached to negative. Because methyl group electron donating group, now it is a negative and this is a positive. Then yes, we get CH2 HC OAC CH, CH3. OH group C plus, H plus goes to CH2 minus. But this H plus, see here, this H plus adds to CH3CO. Then CH3, CH3 CH plus minus, and this plus goes to minus. Then CH plus links with OH minus. CH plus actually is positive, negative, and positive and negative, and this positive here negative. Like this addition occur. And further we will this sodium borohydride. Sodium borohydride. Again in place of water is this one can form CH3, CH, OH, CH3 plus Hz. Mercury comes out and acetic acid. So second step involves removal of mercury. This one, it is called demercuration. First step, oxymercuration. Oxymercuration. Plus oxygen added plus mercury. Therefore, it is called oxymercuration. This one, demercuration by using sodium borohydride. Anyway, these are the molecules. First and last you can see H2O added to propane, but negative part goes to CH, positive part goes to CH2. Then it is called hepagon, or it can follow Marconi. And in this case also there is no formation of carbocation and no rearrangement. So anyway, remember in case of acid catalyzed hydration of alkene and what oxymercuration, demercuration, alcohol is obtained from alkene and addition follows what Marconi curves do, and there is no rearrangement in the molecules. So from alkenes over, next we can study from carbonyl compounds. Second method, from carbonyl compounds. See, what are these carbonyl compounds? If organic molecule contains C double bond O group, this group is carbonyl. And in this mainly you consider RC double bond OH, RC double bond ORH. And this molecule is called aldehyde. Second ketone. First aldehyde, second ketone. But both contain what? Carbonyl. Yes, carbonyl. So then earlier ketone, they are called carbonyl compounds. And further, one more molecule, that is a C double bond OH. If carbonyl group linked with OH, now it is said to be carboxylic acid. It is called carboxylic acid. Now we can convert carbonyl group into alcoholic group. Carbonyl group into alcoholic group by suitable reagents. But in carbonyl compounds, it's what are those aldehydes, ketones, carboxylic acids. But main we consider aldehyde ketone as a carbonyl compound. But in carboxylic acid case, carbonyl group directly attached to hydroxyl group. But it is not said to be alcohol. It is not an alcoholic group. It is carboxylic acid. And if H is removed, it can form carboxylate ion. But about carboxylic acids, we can study next topic. Okay. Now, first we consider aldehyde ketone, then carboxylic acid. So, how to convert these compounds into alcohols? So, after completion of carbon compound, then we can study about action of Grignard reagents. Okay. Carbonyl compound, first one RC double bond OH. Second, RC double bond O dash. First one aldehyde, second ketone. So in syllabus next unit is aldehydes, ketones and carboxylic acids. So these are the formulas of aldehyde ketones. Aldehyde ketone. Okay. So in aldehydes simple molecule, if R equal to H, you can write COH as CHO. If R is H, it is called formaldehyde. It is said to be formaldehyde. If R equal to CH3, acetaldehyde. So in common system, these are written as aldehyde, formaldehyde, acetaldehyde, propanaldehyde, butyraldehyde, etc. And for ketones, CS3, CO, CS3. R and dash may be same or different. Now, if it is same, now it is called ketone, or sorry, simple but ketone, and name of this acetone. Acetone or dimethyl ketone. And if 4 carbons, butanone, 5 carbon, pentanone, or ethyl, methyl ketone, diethyl ketone, etc. So these are called aldehydes and ketone molecules. But in all the cases, what important, CO changes into CH2 or CH4H. C double bond O changes into CH4H by reduction. See, plus hydrogen plus hydrogen. Platinum or palladium or nickel. This is called a catalytic reduction. Catalytic reduction. If you say catalytic reduction, yes, addition of hydrogen in presence of a catalyst such as platinum or palladium or nickel. It is called catalytic reduction. And catalytic reduction of aldehydes ketones. See what they produce. Now I told CO change into CH4H. Because during reaction, see, pi bond break. This is sigma bond. Pi bond break to form free radicals or ions, negative, positive, or free radical. And these radicals combine with H. And this H form hydrogen gas or reducing agents. And to tell you afterwards, what are those reducing agents they can use to convert aldehyde ketone into alcohols. Now first we consider this reagent, that is catalytic reduction method. Anyway, if hydrogen molecule adds to organic molecule, then the process is said to be reduction. It is called reduction. Then so reduction of aldehydes ketones can give. Reduction of aldehydes ketones can give what? Alcohol. Now aldehyde or reduction can form RCHOHH RCHH means HHCH2 OH. Anyway, C double bond O into CHOH. C double bond O into CHOH by reduction method. Okay. But already there is one H, therefore we get CH2. CH plus H, CH2. Now it is 1 degree alcohol. It is a primary alcohol. Means reduction of aldehyde can give. So answer primary. The reduction of ketone, same method. C double bond O into CHOH. Means again by bond shift here, O negative, C positive, or if it breaks symmetrically, then we get dot, means free radical, and they combine with hydrogen. And finally we get R, CH, OH, hydrogen atom. Now this is what primary alcohol, secondary alcohol. So the general conclusion, if it is aldehyde, yes, we get alcohol by reaction. Ketone convert into secondary alcohol. Primary alcohol from aldehyde, secondary alcohol from ketone. Any ketone they take and reduction they can produce what? Secondary alcohol, right? And other reducing agents. If it is not available, we can use other reducing agent that they are lithium, aluminum hydride. Lithium, aluminum hydride. It is a strong reducing agent, the best reducing agent. This also converts aldehyde into primary alcohol and ketone into secondary alcohol. Next, sodium borohydride. Sodium borohydride. Yes, the function of sodium borohydride, it converts what? C double bond O into CH4H. Remember always, sodium borohydride plus any aldehyde ketone. Yes, it converts C double bond O into CH4H. Sodium borohydride or sodium and alcohol. Or so lithium aluminum hydride, sodium borohydride, sodium and alcohol, zinc and LBC. Yes, hydrogen in place of nickel, platinum or cadmium, or those areas we can also use at their unit what atomic hydrogen or nascent hydrogen in the reaction. And they also convert aldehyde into primary alcohol and ketone into secondary alcohol. So in general, I told you how these are converted. Now take examples, different example, aldehyde example and ketone example. You may get in theory paper, how are the following converted and write equations. The type question is expected. Now see here, we are studying about preparation of primary alcohol, secondary alcohol from aldehyde ketone by reduction method. So reducing agents to convert carbonyl compounds such as aldehyde ketone, it may be hydrogen in place of metal such as nickel, platinum, palladium, or we can use even lithium, aluminum hydride, sodium borohydride, sodium and alcohol, zinc and potassium. So all these convert C double bond O into CHOH. C double bond O into CHOH. That's why aldehyde gives a primary alcohol and ketone gives a secondary alcohol. C double bond O become CHOH. Now we will see some examples under what aldehydes and ketones. Examples. First one, CS3 CHO H CHO CS3 CO CS3 acetaldehyde, formaldehyde, acetone, acetaldehyde, formaldehyde, acetone. Now plus hydrogen plus hydrogen on heating it can form. See here, method is same. Convert carbonyl group into CHOH group. Therefore, CH3 CH2OH CH3OH CH2 plus 1H CH3OH. Last CH3 CHOH CH3 CH3 CHOH CH3 CH3 CHOH CH3. Even aromatic compounds we can use benzaldehyde, here acetophenone. It may be benzaldehyde there is a aromatic aldehyde and aromatic ketone acetophenol. Now we get again alcohol. And see all these alcohols. Started into ethanol. Ethanol. Second, methanol. Third, propane to all. Propane to all. Now in a theory paper, such questions are expected. Theory paper. How are the following converted and write equations? You get like this question. How are the following converted and write equations? How do you convert propane to all or propanone to propanol and write equation? Okay, write this equation like this. And instead of using hydrogen nickel, we can also use lithium aluminum hydride or sodium borohydride, NaBH4. Sodium borohydride is a weak reagent, not powerful. But lithium aluminum hydride, a strong reducing agent. That is said to be strong reducing agent. And here we can use any type of reducing agents, but they convert what C double bond O into CHOH. Next, this is using aldehyde ketone I told. Then using carboxylic acid, see how we can prepare alcohols. Carboxylic acid, C double bond OOH. This compound is called carboxylic acid. Then lithium aluminum hydride. The best reagent, lithium aluminum hydride. It is used to convert carbonyl group into CH2 group. C double bond O into CH2 group. Carbonyl into CH2. RCH2OH. Now see here I removed O because during reaction pi bond break and hydrogens, 4 hydrogens from lithium aluminum hydride, and these hydrogens let it be in the form of radicals, and it can form radical like this. And on heating, both the bond break, then 2H here and 2H here. Therefore, H. Right. So we get a primary alcohol. So important when carboxylic acid is reduced by using lithium aluminum hydride, always we get primary alcohol. We get primary alcohol. Carboxylic acid into primary alcohol. Then write examples. Let R equal to CH3, R equal to benzene ring, R equal to C2H5. Write alkyl groups or aryl group. But the important here, conversion of CO into CH2. CO into CH2. And take example, CH3COOH. This compound name, what? Ethanoic acid or acetic acid. Ethanoic acid or acetic acid. Lithium aluminum hydride. Lithium aluminum hydride. Again we get what? Alcoholic group here. CH3CH2OH plus. So in both the cases we get H2 molecule. That's why I told 4 atoms of H added here to convert carboxylic acid into alcohol. So ethanoic acid to ethanol. Now if you take formic acid here, HCOH, then there we get methanol. And instead of this one, write benzene ring, and there we get benzyl alcohol. Correct? Yeah, ethanoic acid to ethanol and benzoic acid to benzyl alcohol. ಸ್ವಲ್ಪ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ತೀನಿ, ಸ್ವಲ್ಪ ಈ ಕಡೆ ತಿರ್ಸಿರೋದು, ಈ ಸೈಡ್ ಬರಲಿ. ನೆಕ್ಸ್ಟ್ ಅದರ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಮೀನ್ಸ್ ಎಸ್ಟಿಕ್ acid, propanoic acid, butyric acid, benzoic acid, all these are used to prepare what? Primary alcohols. But the use of lithium aluminum hydride in such cases, carboxylic acid, in industries, yes, they are not using this one because it is costlier, and only in special compound preparation one can use lithium aluminum hydride. Therefore, in industry they will convert carboxylic acid into its derivatives such as anhydrides, acid chlorides and esters. Then those esters are further converted into what? Alcohols. See how in industry they are converting what? Carboxylic acid into what? Alcohol. First, they will convert carboxylic acid into ester. This is alcohol, carboxylic acid. During heating, yes, reaction occur using concentrated sulfuric acid as dehydrating agent in the reaction. Then we get RCOOR dash. RCOOR dash plus S2. Now it is called ester. RCOOR dash. RCOOR dash. Ester is obtained and this process is called esterification. It is said to be esterification. Now take this ester. Now on this ester, now we can add hydrogen gas and nickel. This is easily available. Okay, hydrogen nickel. Then here again method is same. This group, carbonyl group changed into CH2 group. And this one, here R dash OH, but in this case RCH2OH. Ester group RCH2OH. Then in case of carboxylic acid RCH2OH. Okay. Then RCH2OH plus R dash OH. RCH2OH means this bond break to form HH. Then again this bond break here. Even a carboxylic acid, I told there H2O formation. Here ester, but there direct H2O from OH group. See here. Then the bond break here. Yes, one H here, one H here, one H here, one H here. Therefore, you get RCH2OH. Means C double bond O into CH2OH. CH2OH. This OH becomes H2O in case of carboxylic acid, but in ester, see what happened. Ester, again same, bond breaks here, bond breaks here. Now this part become RCH2OH, R dash OH, one more H added. Therefore again it requires 4 H atoms, here one, here one, here one, here one. Total 4 H required. Yes, again we get what? Primary alcohol. Yes, it may be carboxylic acid or its derivative. We are preparing what? Primary alcohol, and this one may be different. Primary, secondary, tertiary, depend upon R group. If R group contains isopropyl group, then we get secondary alcohol. Tertiary butyl group, tertiary butyl alcohol. Yes, but main the product formed is primary alcohol from carboxylic acid and its derivative. And even we can use its derivatives such as RCO, OCO, R dash or R. It is called acid anhydride, RCOCl. Acid chloride, acid anhydride. Again bond breaks, RCH2OH, RCH2OH. Means acid chlorides, acid anhydrides, esters, carboxylic acid, all these give same product, that is called primary alcohol. They can give primary alcohol. So this is about conversion of carbonyl compounds into what? Primary alcohols. With examples I covered how to convert carbonyl compound into primary alcohols. Next, one more method, there is an important method that is called Grignard reagent method. By using Grignard reagent, see how to prepare. But in haloalkane topic, there I told how to prepare Grignard reagent and what is Grignard reagent. Definition and preparation we studied in haloalkanes and haloarenes. Third method, from Grignard reagent. Okay, so using Grignard reagent, see how to prepare alcohols. Grignard reagent RMgX bond, polar bond, MgX bond also polar, because it is covalent. But main here important part, RMg part, this is RMg. But in RMgX, magnesium positive part and R negative part, because R is more electronegative than magnesium. Hence it attracts electron towards itself, and this is negative. But it is having partial negative charge, positive charge. Hence the molecule is said to be highly polar. Because of high polar nature, yes, it is easily reacting with carbonyl compounds. And that carbonyl compound now, see here, we can use HC double bond OH. This molecule named as formaldehyde. Second, CS3COH, acetaldehyde. Third, CS3COOCH3, and fourth, CS3COOC2H5 or CS3. Formaldehyde, acetaldehyde, acetone, and methyl ethanoate. Methanol, propanone, methyl ethanoate or methyl acetate. Methyl acetate common name, methyl ethanoate iupacin, methyl ethanoate iupacin. Now we will use such molecules to prepare alcohol, yes, by using Grignard reagent. Means how RMGs can add on these type of compound, maybe formaldehyde, aldehyde, ketone and ester. But all these compounds can give only alcohols. Final product formed is alcohol. Okay. Now first we consider formaldehyde. Only formaldehyde can give primary alcohol. Among these four compounds, only formaldehyde can give primary alcohol, and remaining all the three types, there is aldehyde, ketone, ester, and they can give what? Secondary alcohol or tertiary alcohol, but they cannot give which one? Primary alcohols. Now I will tell you how to prepare primary alcohols from formaldehyde and Grignard reagent. Okay, Grignard reagent. But addition of Grignard reagent, RMgX. But actually during reaction, bond break between R and Mg, but bond shift towards R, not towards Mg. Therefore R negative and Mg positive. But when it adds to carbonyl carbon, then yes, what do you get? Addition product is obtained. And that addition product also said to be adduct. That is called adduct. And this is carried out in presence of dry ether. See, why to use dry ether? Because RMGS compounds are unstable at normal temperature and they are solid state compounds, and they may react with moisture, etc., and hence always placed under dry ether to prevent the reactions with compounds present in air or in water. That we cannot use this compound in presence of aqueous medium or atmospheric air. Hence it is always used in presence of dry ether and is highly reactive compound. Next, this compound means formaldehyde contain carbonyl group, and this undergoes again polarization or pi electron shift towards oxygen and carbon become positive and O negative. In presence of reagent, pi electron shifted. Therefore, it is said to be electromeric effect. It is also said to be electromeric effect. Then, when these two reagents mixed, formaldehyde and Grignard reagent in a RBF round bottom flask, and these react within a few minutes, then what do we get? Addition product. That is also solid. Addition product. Now, R minus goes to C plus and Mg plus goes to O minus. R minus adds to C plus. Means Grignard reagent adds to carbon plus first. Therefore, it is called nucleophilic addition. Grignard reagent addition with what carbonyl compound says, or addition reaction follows what nucleophilic, not electrophilic, because negative charge adds to C plus of carbonyl compound. It is said to be what nucleophilic addition. It is called nucleophilic addition. So nucleophilic addition of Grignard reagent occur on carbonyl carbon to give adduct. Now write adduct formula. Correct? Adduct formula. HCOH. Here first you write HCHO because pi bond shifted here and this becomes single bonded. Then OMGX because positive negative there is formation of a bond. Mg dash O you get because pi bond shifted with electron pair and electron pair equal to here bond. Next, R negative with bond here with bond. R negative with C plus can form RC bond. Now it is said to be adduct. That is said to be adduct or addition product is obtained. It is called addition product. And further upon hydrolysis catalyzed by acid. It is called acid catalyzed hydration or acid hydrolysis. It is called acid hydrolysis. But hydrolysis occur at OMG bond. Here hydrolysis occur, not here, because it is highly polar compared to this one. Then HOH from what? S to O, HOH, because OH negative goes to Mg, H positive goes to O. Therefore, we get finally right. Now it is said to be primary alcohol. Now, just to observe carefully, it is important method. Even in CET, NEET, competitive exams, questions on Grignard reagent we get. And reaction is lengthy, but it is very simple. First addition occur, we are tried formula of adduct, and further upon hydrolysis they can give final product. But to prepare primary alcohol, see why it is called primary? In previous classes I told, if OH group linked with the carbon having 2H, it is called primary alcohol. That's why I told this compound is said to be primary alcohol. To prepare primary alcohol from Grignard reagent, compulsorily you have to use formaldehyde or methanol, formaldehyde or methanol. And we cannot use other compound to prepare primary alcohol using Grignard reagent. Okay. Next, to get other alcohols like second alcohol, tertiary alcohol, etc., and using what reagents, other reagents we can also use. but method is same. This method you have to follow to prepare what alcohols by using Grignard reagent. Okay, and that one plus remaining part, that is the properties and reactions, mechanisms. Remaining part we can study in next video. There is a from Grignard reagent other reactions plus physical properties we can consider those reactions and properties. Plus some question answers also we will discuss in next class. There is a question answer from NCERT book. Okay, some in-text questions are there. Question with solutions are given in NCERT book. And those are important questions, and those questions I want to discuss. Okay, in the next video we'll cover those.